This video is going to cover Section 2.2, quadratic functions, and it's got quite a few targets that it's going to cover. You'll notice that it covers two targets that we got in Chapter 1, and that's finding x and y intercepts, and then also finding domain and range. I'm not going to read all of these ones, but this mostly should be review. It's regarding parabolas, quadratic equations, calculating the maximum and minimum, which is the vertex, and then converting back and forth from the two different types of quadratic equations. So first of all, standard form or general form of a quadratic equation is the ax squared plus bx plus c. You need this form to use the quadratic formula, which is one way to find x-intercepts. And the quadratic formula is x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. You will have to be able to find x-intercepts by hand, either using this or factoring, but there will be times where I will let you use the program on your calculator. And so then use the quadratic formula to find the x-intercepts of y equals x squared plus 4x minus 21. Go ahead and try this on your own and then come back to the video and see the answers. So using the formula, my a is what's in front of x squared, b is in front of x, and then the negative 21 is my c value. So I'm going to pop those into the quadratic formula. So you'll see a negative 4 out in front, the 4 squared minus 4 times a times negative 21 all over 2 times 1. When I simplify that, I get negative 4 plus or minus the square root of 16 plus 84 all over 2. Take that one step further, negative 4 plus or minus the square root of 100 over 2. Simplify that one step further, and you get negative 4 plus or minus 10 over 2. And so this is where you get your two x-intercepts, when you add 10 and then when you subtract 10. So one of my x-intercepts is going to be 3, and then the other x-intercept is going to be a negative 7. And you could also get this when you factor the equation as well. Vertex form of a quadratic equation is y equals a times x minus h squared plus k. And now you'll have to learn how to go back and forth from these two. So it's important to know each part of this equation. And one thing to take note of is that the book calls this standard form, and the last form that I gave you is actually called standard form. So I just want to make sure that we call this vertex or graphing form because it's easy to graph and to see the vertex. Which reminds me, the vertex is at h comma k. We did do this in chapter 1 as well. And then all of these are the transformations of the parabola, which I'm not going to go through because we did this last chapter. So a is that stretch factor, h is the horizontal shift, and then k is the vertical shift. So writing the equation of a parabola in vertex or graphing form. So the very first thing, this is when you're given a word problem. In order to figure out the equation, you want to first sketch a picture and then label the key information. And the key information would be the vertex and one other point. The second step would be to plug the vertex in for h and k. The third step, plug in the other point the parabola goes through in for x and y. Step 4 would be to solve for a, your stretch factor. Step 5 would be substitute the vertex and a into the equation. And then this would be your equation that you use to answer any questions about the problem. Your first example, and it's not a word problem, but it's going to apply when we do come to word problems in class. It says to find an equation for the parabola that has its vertex at 1, 2 and passes through the point 3, negative 6. So the vertex 1, 2 goes in for h and k. My 3, negative 6 goes in for x and y, and so then we have to solve for our stretch factor. Remember that you can't, the 3 minus 1 squared and then plus the 2, you can't combine those because of order of operations. So I'm going to subtract 2 from both sides to get the negative 8 equals a times 2 squared. Then I get negative 8 equals a times 4. Divide both sides by 4, don't divide both sides by negative 8. That's a common algebraic error that people make. So make sure you divide both sides by 4. That gives our stretch factor a value of negative 2. And so then my equation would be y equals negative 2 x minus 1 squared plus 2. Graphing a quadratic function in graphing form. First thing you want to do is plot your vertex at hk, and then you want to find the x-intercepts by plugging in 0 for y, or for f of x, and then plot the coordinates. Third step would be to find the y-intercept by plugging in 0 for x and plot those coordinates, and then just connect the dots. Your domain for a parabola is always going to be all reals. Your range is going to be y is greater than or equal to k if you have a positive stretch factor, and it's going to be less than or equal to k if you have a negative stretch factor. Converting a quadratic function into standard form converting a quadratic function in standard form to graphing or vertex form. The first thing you want to do is determine the x value of the vertex using the formula h equals the opposite of b over 2a. Now, one thing you guys did in Algebra 2 was it was called completing the square, and that's how you went from standard form to graphing form, but in pre-calc we're actually going to use an easier method. So h equals the opposite of b over 2a, and this is when you're given the equation in standard form. This will be our x value of the vertex. If you have a stretch factor that is greater than 0, then your minimum is going to occur at your h value. If your stretch factor is less than 0, then you have a maximum there. The second step you want to do is solve for the y value of the vertex by plugging h into the standard equation that you're given. Next, you're going to want to write in the stretch factor into the graphing form equation, and the stretch factor is actually the same in standard form as it is in graphing form. So y equals a x minus h squared plus k, and then solve for the x and y intercepts and plot, and then connect the dots. So applications of quadratics. Let's do this first example. The function f of x equals 0.4x squared minus 36x plus 1,000 models the number of accidents per 50 million miles driven for drivers x years old, where x is between 16 and 74. So now this is a quadratic equation, and generally your domain is all real numbers, but since we're talking about drivers, you have to be 16 years old to be a driver, so our domain is the age has to start at 16, and then on average, elderly drivers stop driving on the road about 74. Now there are exceptions, but this equation only models drivers between the ages of 16 and 74. So the first thing it says is, what is the age of a driver having the least number of accidents? So this least should be a red flag for you that we are looking to find the minimum of the parabola. So we're going to plug it into the formula. H equals the opposite, so this is always going to be there, and then we plug in our b value, which is negative 36, over 2 times a, which is 0.4, and when I simplify that, I get 45 years old. That's the age of the driver having the least number of accidents. So then it says, what is the minimum number of car accidents per 50 million miles driven? Well, my 45 years of age was the x value of the vertex, and b is asking for what is the y value of the vertex. So I'm going to plug the 45 years into my standard equation and solve for it. And when I simplify that, I get 190 accidents. And then the last example that I have is maximizing area, and this is actually going to use what we learned in the last section of Chapter 1 when it came to writing equations of area of rectangles and using the perimeter as well to write the area formula in one variable. So for example, it says, let's say you have enclosed 100 yards of fencing to enclose a rectangular region. Find the dimensions of a rectangle that maximize the enclosed area. What is the maximum area? In A, it says express the area as a function in one variable. So I'm going to give you the steps that it takes to find the maximum area. So I'm breaking this down for you. So the first thing we need to do is get an area formula. So we know that area of a rectangle is base times height, or x times y. The perimeter is always going to be 2x plus 2y, and in this case we're given that the perimeter is 100. So I want to solve for y. So I'm going to subtract 2x from both sides and then divide by 2, so I get y equals 50 minus x. Then I'm going to plug the y equals 50 minus x into the area formula in place of y, so area equals x times 50 minus x, and I simplify that to get 50x minus x squared. The second part, it says to write the function in standard form, so I just want to rearrange my formula so that I have my largest exponent first and then I descend the exponents by 1. Then it says to calculate the x value of the vertex. Well, use the formula h equals the opposite of b over 2a. So in this case I have the opposite of 50. 50 is my b value over 2 times a, -1, and I get 25 yards. And then in D, it said to calculate the maximum area, find the y value of the vertex by plugging h into the equation. So here's my x value of the vertex that gives me, that it's going to give me the maximum area. So when I plug 25 in, I get 625 yards squared. So this video covered quite a bit and I went kind of fast. So we are going to be applying this to our homework and the group work in class.